This is lecture 7, first example, and we've been talking about main memory. And when I say main memory, I am referring to data memory because main memory also holds program memory, but we typically don't write that. We just read it, and so that's not what we're interested in. We're interested in swapping data out from the register file back and forth between main memory. And so essentially that means load and store instructions. Load instruction, I'm taking something from memory, putting it in a register, and then a store instruction, I'm taking something from a register and putting it in memory. And so here's the example here. I already put a mistake in here. Essentially what I'm going to do here is swap data in two locations in memory. And the idea here, the address in memory where I want to swap that data is x10. So the first x10 has an address. The address in x10 is the address of the first piece of data. The next piece of data is the next address location. So the key in this thing, for this first time we go through this, is we're working with word memory. It's a byte addressable, but we're actually working with words, so we have to take that into account in the problem here. So you'll see when it comes up. So the first piece of data is actually stored at the address in x10. The second piece of data, which is the one we want to swap, is stored at the address whatever's in x10 plus 4 because it's word data. Okay, so that we have to do that proper here. So let's do this. So this is a subroutine. I'll just say swap. How about swap word here? Okay, so what I'm going to do is I got to go get the data, then swap it, and then put it back in memory. So I'm going to load it from memory. I'm going to swap it, and then I'm going to store it in memory. So I'm going to read it, then write it, which means load it, then store it. So the first thing I need to do is to go get it. So it doesn't matter where I put it, but the data is located at x10. So let's do this thing. It's a load, and it's word data. We'll just say x20. And the address is going to be 0 with no offset and x10. Okay, x10 has an address, so I'm using it as the base address with no offset. Okay, so I got to go get some more data. This is load word, doesn't matter where I put it, but it's the next piece of data. Next piece of data, because I'm working with words, is 4 beyond x10. Okay, then and you'll see this. We'll redo this problem, and it'll be a little bit different later. And then essentially what I need to do is store that data. x21, that's the data I just got. I'm going to store it at x10. So I'm storing it at the place where I got the first data from. And similarly, I'm going to take the data in x20 and store it where I got the data in x21. Okay, and then I'm done with this program. Okay, so this is super important to understand what's going on here, is that once again, this is a base address, this is an offset. And the offset, and the first way I did this is based on the fact that I'm using words, and we're going to redo this, and you're going to see the difference on this one. So I'm going to do swap. We'll do swap bytes. So I'm just going to cheat over here. It's load byte. Doesn't really matter whether I load it as unsigned or signed. It will work either way. And I'm going to put it in x20 again, and it's going to be 0x10. But the notion is I'm going to load another byte, x21, and check it out. This is the difference. This is the offset now. It's offset by 1, not 4, because I'm now working with bytes. And now I'm going to store it, x21, we'll do it's stored at where I got the first data from, and then I am going to store x20 where I got the second piece of data from. And so these should match, hopefully. Looks good. And then I can return on this one, and we'll do it one more time. We'll do a swap half word. Swap half word. Load. Oops, this dumb pen. Load half word x20. And seriously, once I do this one time, I'm plagiarizing myself and copying the code because it's so much the same. So here's the money shot right here. Because I'm using half words, I advance that offset by 2, and so it's x10 again. And so this is store half x21 0 x10, and store half x20 2 x10, and that does the swapping once again, and then I can return. Okay, so really important to understand that. Once again, memory is byte addressable, and I have to account for that when I jump around in memory, and I typically account for it in using the offsets. So here's the byte. You can see that's a 1. Here's the words. You can see that's a 4. And here's the half words. You can see I have to jump around by 2. And I think this is an old solution. I did this a while ago. This is only the word solution, and looks good.